SLA stands for service level agreements. So SLA is actually there between the cloud service provider and the consumer. And this SLA specifies a number of conditions for different kind of service quality parameters. So SLA must specify the sufficient resources such as the CPU, such as the memory, such as the bandwidth that the user can use for a defined period of time. So SLA defines uh, for a particular period of time what will be the maximum usage of CPU, memory, and internet bandwidth, and etc. for the different customers, for the different consumers. And the service provider has to meet out all the requirements which are listed in this SLA. So SLA stands for Service Level Agreement, which is a agreement between the consumer and the service provider. And we know that if the resources are not provisioned correctly, there may be a case of under provisioning of resources, and there may be a case of over provisioning of resources. So if the resources are under provisioned, it means the sufficient resources are not made available to the customer. It means that the service provider has to pay a lot of penalty to the consumer because he is actually not satisfying the conditions listed in the SLA. In case of the over provisioning of resources, if more resources are being provided to the consumer than the listed number of resources in the SLA, it will be actually a wastage of or underutilization of resources. Okay, so both the situations, either over provisioning and under provisioning or under provisioning, both are not favorable, right? And what can happen in such scenarios? The service provider has to find out some mechanism so that the right amount of resources can be provisioned, can be made available to the consumers. So what is the idea? The idea is to deploy an autonomous system which can efficiently provide the resources to different users, okay, in real time. Okay, now what is the main difficulty into this? It is not possible to predict the consumer demand at a particular time because the consumer demand may vary with the period of time. And it is not possible to predict the software and the hardware failures. They may occur in real time, they may occur all of a sudden. And the different consumers, they are actually using different kind of devices to access all these cloud computing services. So there is a case of heterogeneity of services. There is a case of power management. There is a conflict in signed SLAs because different consumers, they will be having different SLAs with the service providers. Okay, so service provider has to meet out the requirements of all the customers, all the consumers, and the service provider is expected to satisfy all the conditions listed in the SLAs for different customers, for different consumers. Okay, so these are the main difficulties which are there to provision the resources in real time for the different consumers. So what is the idea? Depending upon the demand of the consumer, the number of VMs should be provisioned to the consumer. So efficient virtual machine provisioning depends upon the cloud architecture and management of cloud infrastructure. And the cloud infrastructure and management is actually the responsibility of the cloud service provider. Resource provisioning schemes also demand faster discovery of services and data in cloud computing infrastructure. We know that in case of resource provisioning, because different consumers, they are accessing different kind of cloud computing services. So this resource provisioning also includes the faster discovery of different cloud computing services and data into this cloud computing infrastructure. Also, what is the other requirement? The other requirement is the efficient installation of virtual machines. So if the consumer is requiring more virtual machines at a certain time, the cloud architecture should be able to install these virtual machines in real time. There should not be any great amount of delay into this. And sometime the virtual machine is migrating from one cloud to another cloud, from one cloud to another cloud. So in that case, a live virtual machine migration should be possible, and it may be the case that there may be unpredictable failures in the hardware as well as in software. So in such case, the system should be able to recover from these unexpected or all of a sudden failures which are happening in the cloud computing services. So to deploy the virtual machines, the users treat them as physical hosts with customized operating system for specific applications. So we know that whenever the different consumers, they are actually using the virtual machines, they are treating the virtual machines as a physical kind of thing. And each virtual machine is having its own operating system, which is actually customized according to the consumer and according to the specific applications which are being run over that virtual machine. For example, there is a cloud service provided by the Amazon, that is the Amazon Elastic Cloud 2, which is actually using the Zen as a virtual machine monitor. And the same virtual machine monitor is also used in the IBM's Blue Cloud. So IBM's Blue Cloud is the cloud from the IBM, and Amazon EC2 is the cloud, which is a storage cloud for from the Amazon. Amazon EC2 stands for Amazon Elastic Cloud 2. So what happens in Amazon EC2 platform? It actually has some predefined virtual machine templates. Okay, like if you are creating your CV, so you know that you will find some already predefined templates, and you can use some predefined templates to create your curriculum uh, uh, or biodata. Okay, so what the user can do in this case, the different users, they can choose different kind of virtual machines. They can see into the templates and they can use the particular template of the virtual machine for the kind of requirement they have. However, the IBM Blue Cloud does not provide any virtual machine template, and IBM Blue Cloud does not provide any virtual machine template which is provided by the EC2 platform from Amazon. And in general, any type of virtual machine can run onto this virtual machine monitor, which is called Zen. Microsoft applies virtualization in its Microsoft Azure Cloud Platform, and the service provider should offer resource economic services. What does it mean by resource economic services? Because if the service provider is providing more than the required resources, then these resources will not be going to be economic, because each and every resource is costing the service provider. So service provider has to provide the demanded resources, and that's why the service provider need to offer resource economic services to different cloud consumers. Other things which can be done, like power efficient schemes for caching. You know, caching is a mechanism which is actually going to store your recently accessed data, and in case you need the same data again and again, the same data can be retrieved from the cache. So there may be some schemes for caching, there may be a scheme for query processing, there may be a scheme for thermal management, okay, which are also mandatory in case of data centers. So what is data centers? Data centers are the centers with a huge building in which a number of computer systems are located, and which are responsible for providing services to different cloud consumers. So it is also necessary to reduce the energy waste by the heat dissipation from the data centers. And public and private clouds, they promise to streamline the on-demand provisioning of software and hardware and data as a service, and that's why they achieve the economy of scale in IT deployment and operation. So both kind of clouds, public and private clouds, they are capable to provision the resources. It could be the hardware, it could be the software, it could be the data, and that's why they provide a scalability in case of assessment, in case of utilization of all these different resources in this cloud computing paradigm. So what are the resource provisioning methods? So there are different, there are mainly 3 to 4 resource provisioning methods. So we will see each and every method one by one. Okay. So why do we require this resource provisioning? So you see in this figure, there are 3 figures, A, B, C. Figure A shows the capacity of the cloud and the demand. So you see a curve between the demand and the capacity, and you see a graph between the time and the resources. So you see what is the demand. So demand is varying like this. In the first graph, you see the demand is continuously changing with the period of time. Okay, and what is the capacity of the cloud in terms of resources? This red horizontal line indicates the capacity of the resources available by the cloud service provider. So what happens? All the demands are going to be satisfied, but you see sometime the demand is very less, but the capacity is high. So what happens? At that time, when the demand is very poor and the capacity is very high, the resources are not being utilized. So this is the underutilization of the resources. So figure A shows the resource provisioning, okay, which is what the not utilization of the, not a good utilization of the resources available into the cloud. Okay, the second second figure B shows the under provisioning. Okay, what is under provisioning? The demand is high and the capacity is low. So you see that the number of resources are low than compared to the demand. So that's why the amount of resources available by the cloud, they are not able to satisfy the demand of the different consumers as the time goes up. Okay, so you see this portion shows that the demand is high at this time and the capacity is not such that it is able to meet out the demands of the customers. So that is called under provisioning. The resources are not available, the right amount of resources are not available to satisfy the consumer demands. Then you see another example, that is the another example of under provisioning. So what happens in this figure C? You see that the demand of the resources is gradually decreasing. Okay, so initially you see that the under provisioning is there, and gradually when the demand is slightly decreasing after a period of time, so this figure C is basically representing under provisioning as well as over provisioning. Okay, initially it is under provisioning, and with the period of time the demand is going to decrease and the capacity is going to be constant all the time. In that case, it is the number of resources are available and they are not going to be utilized. Okay, so figure C shows the case of under and over provisioning. Figure C shows the case of under and over provisioning, okay, with the period of time. So that's why we see that in both of the cases, under provisioning as well as in over provisioning, okay, uh, the situation is not. In case of the under provisioning, the resources are not available. The right amount of resources are not provisioned, made available to the consumers. So the service provider has to pay a lot of penalty to the consumer. And in case of the over provisioning, the amount of resources are available than the actual demand. And that's why sometimes you see that a number of resources are not going to be utilized by the consumers, and the cost of the available resources uh, is going to be bear by service provider. So both situations are not. Okay. So what are the resource provisioning methods? So there are, you see here, three resource provisioning methods. One is the demand driven method, another is event driven method, another is popularity driven method. So first method is the demand driven method. So demand driven method provides, this method assumes static or constant number of resources to be available for the different consumers, and it has been used in grid computing for a couple of years. Okay, so what is the idea? Uh, Idea is that for different consumers, depending upon the SLAs conditions, the cloud service provider is going to estimate uh, the demand from the consumers. And then after, it is actually deciding some fixed number of resources to be made available all the time to these different consumers. The second technique is the event driven method. So in case of the event driven method, uh, the number of resources to be provisioned is decided by the event. So we know that if there is some event that is going to happen in the future, based upon that, the amount of resources can be decided. For example, you know that uh, in India, if you talk about the income tax return, so many people, the last date of the income tax return generally is 31st of August for all the people in the India. So all the people are expected to use this income tax platform by the government of India to file their returns. So in the month of August, peak number of users will be accessing the website of this income tax department of India to file their returns. Okay, so depending upon the event, we can decide how many resources need to be provisioned for a certain period of time. So this method is actually called the event driven method. So based upon the event, we estimate the number of resources which should be provisioned to the consumers to satisfy the needs or demands of the consumers. Are you getting my point, everybody? Yes, any question? Are you getting my point? Third is what the popularity driven method. So in case of the popularity driven method, what is happening? We know that which kind of applications are going to be popular on the internet based upon the usage of these applications. So we can increase the number of instances of these applications onto the cloud. Right. So depending upon the popularity of the particular platform, depending upon the popularity of a particular application or the resource, we actually try to measure the uh, capacity of the resource to be provisioned to different consumers. Now we will discuss each and every method in detail. So first is the demand driven resource provisioning. So this method is going to add or remove computing instances based on the current utilization level of the allocated resources. So all the time it will see what is the current utilization level of the allocated resources. Based upon that, this method will decide how many resources are to be added and how many resources are to be removed from the cloud. For example, the demand-driven method automatically allocates 2 Xeon processors for the user application. When the user was using one Xeon processor for more than 60% of the time for an extended period. All of you are aware what is the processor? I3, you know, is the processor, I5, I7, they are the processors. Similarly, a Xeon is a processor. So what this demand driven method will do, if the user is using one Xeon processor up to 60%, the utilization of the processor is 60% for a particular period of time, then this demand driven method is going to add one more Xeon processor to the user. Okay, so basically this is called the demand drive based upon the certain threshold. So threshold is here the 60% utilization. It could be the 90%. Depending upon this threshold, the demand driven method will be adding more processors to this user application. So in general, what happens when a resource has surpassed the threshold for a certain amount of time, this demand driven method is going to add some resource based upon the demand. So when the resource utilization is below the threshold value for a certain period of time, then the resources can be taken away from the cloud. So if the resource utilization is going below than the specified threshold for a certain period of time, then the amount of resources can be deallocated from the cloud. So Amazon implements such as auto scale feature in its EC2 platform. And this method is easy to implement because we can specify the threshold for different kind of resources, and based upon the threshold, the system can automatically decide whether to add or remove some resource from the cloud. Okay, but this scheme does not work right if the workload changes abruptly. So if the demand is changing all of a sudden, in that case, this scheme is not good. This scheme will not be able to meet out the demands of the consumers. So if we assume that the demand of the resources does not change all of a sudden, in that case, this scheme is easy to implement and easy to utilize. Okay, so you see a graph here. So you see the time in number of days, and you see the percentage of CPU utilization on the y-axis. So on the x-axis, you see the time in number of days, and on the y-axis, you see the CPU utilization percentage. Right, and on this axis, on the left side, on the right side, you see 0, 2, 4, 6, 8. These are the numbers which are indicating the number of nodes or number of virtual machines. Okay, so you see as the CPU utilization increases, this demand driven method is going to add more number of virtual machines. Okay, so you see this graph, it is actually showing the number of nodes varying with the period of time. And this orange color in this graph is showing the CPU load in terms of CPU utilization, in terms of percentage CPU utilization. So you see, as the CPU utilization grows up, the number of virtual machines or the number of nodes allocated, they are increasing, and after this period of time, they are actually decreasing. Okay, so this is the graph that is actually showing the demand driven method. Depending upon the threshold value, the number of virtual machines, the number of virtual machines will be allocated more and more. And when the demand is low, the number of virtual machines will be deallocated, and that will reduce the number of virtual machines available at that period of time. So you see here, you see at this point here, what is happening? The percentage utilization is dropping up, and that's why the number of nodes, the number of virtual machines, this is also going to be reduced. The another method is what? Event-driven resource provisioning method. So this method actually is there to add or remove virtual machines instances based upon some specific event. Okay, so we know that there are some seasonal or there are some other events like Christmas or lunar, New Year, or other kind of events. Okay, depending upon the event, uh, uh, we can analyze how many resources would be needed at that period of time, and we are expecting that the number of users would be going over that period of time for a certain period of time, and the number of users, they are going to be decreased after the event is over. Okay, so in this method is actually analyzing and trying to determine the peak demand. The peak demand in terms of the number of users, in terms of the number of resources before the event is going to happen. And that's why this method is going to result in the minimal loss of quality of service. You know that there are some parameters of quality of service, and this method, if it is going to be successful, the quality of service parameters will be as good as it would be possible. So if the event is predicted correctly, if it is possible to predict the resource requirement before the event, in that case, the quality of service would be very, very good in case of this method. Otherwise, if the number of resources are not correctly predicted before the event, in that case, it might happen that some resources are going to be wasted. Okay, and that would be the loss of the cloud service provider. Okay, so you see here, after this 43 days, what is happening? There is some event, and that's why the number of virtual machines, the number of nodes allocated, they are increasing. Okay, so it is basically, you see this curve that actually shows the number of virtual machine instances which are going to be allocated during this period of event. The third method is known as the popularity driven resource provisioning method. So in this method, we know that we can search over the internet for popular applications, and we can know that these are going to be the popular applications, or these are going to be the popular platforms for the different consumers, and depending upon that, to meet out that demand, it actually is going to allocate the right amount of resources to the different consumers. So in this scheme also, this is actually calculating or determining the increased traffic with the popularity, and if the predicted requirement of the resources is correct, then of course the quality of service parameter, they are going to be very, very good. But if the predicted popularity, if the predicted amount of resources is not correct, that it could either lead to underutilization or it could lead to overutilization of resources. So resources may be wasted if the traffic does not occur as expected. If the traffic is very, very low then compared to the available resources, in that case, the resources are not going to be utilized and they are going to be wasted. So there is a figure of this Amazon EC2, which is showing the performance by CPU utilization rate and the number of virtual machines provisioned. So you see this diagram, So on the y-axis, you see the CPU utilization percentage. On the x-axis, you see the number of days. On the right side, you see the number of nodes or the number of virtual machines allocated by the cloud. Okay, so you see this first black curve that is actually indicating the demand in terms of CPU utilization, and this curve is actually showing the number of nodes allocated or the number of virtual machines allocated by the cloud. So as the CPU utilization increases with the period of time, the number of nodes allocated by the cloud, they are increasing. As the CPU utilization is dropping after a certain period of time, the number of nodes which are allocated for these different consumers, they are going to be decreased into this order. Right. So this is what the example of the EC2 performance, which has been collected from this University of Southern California using 3 resource provisioning methods. Okay, so this is what the example of the popularity driver. So we have seen 3 figures. This is what the example of the event driver, and this is what the example of the demand driver. So what we have discussed? We have discussed 3 methods. One is the event driven, demand driven, and popularity driven resource provisioning method. Yes, any confusion into this?